When working with three-phase power, the math is a lot easier if you use rectangular form or polar form. So we're going to take a look at rectangular form, and we're going to take a three-phase power here, and we're going to plot it on this complex plane over here. Now, in order to do that, we need to know complex numbers, and they're just real and imaginary numbers. Now, real numbers are along this x-axis. We have positive on this side, negative on this side. Now, these imaginary numbers, mathematicians use the letter I for imaginary, but George Ohm used I for intensity or current, so we use the lowercase j for imaginary. Now, j is equal to the square root of -1. Now, if we put -1 in a calculator and we try to do the square root of that, it's just going to come up with a error, so that can't happen. But what it allows us to do is if we multiply by this j, it allows us to rotate a phasor around this complex plane counterclockwise, okay? So positive j is up on the top, negative j is down below, down here. So let's plot this phase A on this complex plane. Now, I'm going to use 1 as the magnitude. It could be 1 volt, 1 amp. We could use an RMS value of 120 volts or 10 amp current, but I'm just going to use 1. That way, when we're done, we can multiply by any voltage or current we want. 120 volts, 277, 480 volts. So phase A here, it's in phase, and it's just going to be, the magnitude is going to be 1. This is the magnitude along here in this circle here. And to write the real number is going to be 1, and our imaginary number, well, we're not rotating anywhere, it's right at 0, so it's just going to be plus j0 here. So no rotation on that one. Now, phase B, it's 120 degrees apart from phase A, so we want to plot this point up here in rectangular form. So what we do is we take the cosine of 120 degrees, and that's equal to minus 0.5, and that's on our x-axis, that's our real number. And then we take the sine of 120 degrees, and that's going to be 0.866, and that's going to be our imaginary number coming up this way. So imaginary numbers up this way are positive, imaginary numbers down this way are negative. So we have a real number of minus 0.5 and an imaginary number of 0.866. So this point up here is going to be minus 5 plus j 0.866. Okay. Now that complex number, that gives us the magnitude. It gives us our angle and everything we want to know about this phasor. And it makes the math a lot easier to use. So now, if we want to find the magnitude, we know this. All we have to do is use Pythagoras Theorem here, and we can take our real number squared plus imaginary number squared, and then we square root that, and that comes out to 1. So this is going to be 1 right here. Now, phase C here, it's 120 degrees away from A and another 120 degrees away from B, so that's 240 degrees. So we take 240 degrees over here. So what we do there is we take the cosine of 240 degrees. Now it happens to be minus 0.5 also, right? So we head over this way, minus 0.5 with a real number, and the sine of 240 degrees is going to be a minus 0.866, okay? And that's coming down this way here. So we drop down this way, so our hypotenuse here is still going to be 1, okay? So this point here is B phase is denoted with 0.5 plus j of 0.866, and C phase is 0.5 minus 0.866, okay? So here they are over here. So these three phases can be written just like this. Now in polar form, it's written like this. To get to polar form, we just take our hypotenuse. We write that down first. So we just take the Pythagoras Theorem here, and we get our 1. Okay, and to find the angle, this is our angle over here. We just take our we take the imaginary number divided by the real number, and then we take the arctangent of that, okay? And it's actually 60 degrees, but that's this angle here, but we know that we want this 120 degrees over here. And if you divide it into the minus, 0.87, it comes out to minus, and so we know that it's 240 degrees around. You could write it as a minus 120 if you want, but it's just easier to have it in the 240 like that. Now, say we have a RMS value of 120, so we just take our 120 times our, say on this phase here, times our 0.5 plus our J of 0.866. So we can multiply those out, and it comes out to 60, half of the 120, and then plus J 103.92. You'll see it as 60 plus J 104, okay? So a lot of times they'll, if they're dealing with 120 volts on, say on a Y system, they'll write down, you'll see 60 plus J 104, okay, or minus 104, and that's your phasors, okay. So that's the same, going to be the same angle, and same phase, okay. So that just makes the math a lot easier when you go to add and subtract these things. And maybe in the next video or so we'll take a look at that. But that's all there is to rectangular form. And thank you.